This is Year 8 separation techniques. Right now I can guarantee that these are going to be talked about in Year 9, Year 10 and Year 11. It's one of those topics that always comes up, and something on this kind of presentation is going to be on your exam at the end of Year 11. No doubt about it. Right, now just do a few words first. We've got solute, solvent and solution. You need to understand what each one of those words is and how they kind of interact. So a solute is the substance that's being dissolved. So what I'm going to do is at the bottom here, I'm going to draw a cup of coffee. Okay, and the solute, the substance being dissolved in this cup of coffee, is the coffee granules or the sugar. The solvent is the liquid that the solute dissolves in. So what am I dissolving my coffee and sugar in? It's water. The solution is the solvent and the solute together. So my overall solution then is the cup of coffee. Now we're going to go through 5 separation techniques: distillation, evaporation, crystallization, chromatography and filtration. Okay, filtration first. Okay, right, now filtration, what you do is you put your sample in the top. Okay, you've got a filter funnel. It says there excess copper 2 oxide. That's from a required practical. And then what happens is the filtrate drips down into the bottom. Now filtration is used to separate insoluble solids from the solution. So the key to this is insoluble. Insoluble means it doesn't dissolve. And that's then why copper 2 oxide is on there, because copper 2 oxide is insoluble. It's black, and then what you'll do is you'll see a black powder appearing in there. So key to filtration is separating out insoluble solids. Sand and water. Sand is insoluble. Evaporation, right? So this is then using some of the S words. It's removing a solvent from a solution. Okay, so it's getting rid of the liquid from a solution, leaving behind the solute. So what I've got here is I've got copper sulfate solution in the top there, which is a lovely blue colour. Bunsen burner, and then what I'm doing is I'm heating the boiling water. The boiling water is then warming up the evaporating basin. So basically what happens is the liquid then boils off slower. Okay, it's acting like a water bath. So evaporation, you're removing the solvent from the solution, leaving the solute. Crystallization, I always think this is a bit similar to evaporation really, but the idea is to produce solid crystals. So you start off with a solution, and then what you do is you filter it out into an evaporating basin. Then you evaporate to get rid of the volume, so you just kind of evaporate a fair bit. Once it's hot, put it into a dish, okay, and then leave it over time. Crystals will then form when the actual solution is then, when the actual liquid, the solvent, has all disappeared. So that is crystallization. And it is to produce solid crystals from a solution evaporating off the solvent. And the solid crystals are your solute. Distillation. Okay, so what I've got here, I'm not going to do salt water, don't like salt water. What I'm going to do is I'm going to do ethanol. Got right? Ethanol and water. Okay, so what I've got in this bottom bit here, I've got ethanol and water, and I heat it up. At 80 degrees C, the ethanol boils. And when the ethanol boils, what it does, it goes up here into the condenser. That sort of darker area around the outside is water. The ethanol goes into the condenser, turns back into a liquid, and then drips out. And basically what I've got at the bottom here, I've got near enough 100% pure ethanol. Okay, now I said before it boils at 80 degrees C. So distillation is where you separate out 2 liquids with different boiling points. So ethanol boils at 80 degrees, so therefore the water stays in the distillation flask, the round bottom flask. So distillation is separating out 2 liquids with different boiling points. Chromatography, right? So what you got is you got your piece of paper. There's a piece of paper. Across the bottom you put your ink dots, okay, and then you use water as the solvent. You do a pencil line at the bottom, maybe a centimetre from the bottom of the piece of paper. You leave it in there for 8, 9, 10, 11, 12 minutes until it gets to the top of the piece of paper. Then what you do, you pull it out and you dry it. Now, chromatography separates a mixture of chemicals based on its solubility. So the more soluble it is, the further it goes up the piece of paper. So chromatography is based on solubility. Right, you've got your 5 separation techniques there. Now what you need to do is you need to write them out first. Once you've written them out, you then need to explain how they actually separate during that kind of experiment.